Good day, everybody. Welcome to our 1.06 quiz review. So, one of the things that I'll be doing for you throughout this year is I'll be reviewing the types of problems that are going to show up on the quizzes and the tests, the multiple choice ones, as well as like the midterm and so forth. So, these reviews will be a little quicker, but just a chance to remind you of the things that we've done for this section and what'll be on the quiz. So, what's going to be on this quiz? Well, number one, you have to solve quadratic equations and inequalities. Okay? So we want to kind of go over that. We have to be able to solve rational equations and inequalities and radical equation and inequalities. And then we want to be aware of how these might show up in a story problem, but the method of solutions will be the same. So let's do a quick review of each one of these. So quadratic equations and inequalities. All right, let's look at the quadratics. So for a quadratic equation and inequality, in general, you must set it equal to 0 or less than greater than 0. Okay? So for a quadratic, you're always trying to move things onto the same side. Okay? Then you must factor it or use the quadratic formula. And when you do that, okay, you are essentially solving the equation, but for an equality, what's happening is you will be just solving it. But for an inequality, less than, greater than, you're going to be solving for the zeros. In other words, the border lines between the solutions. All right? And then for an equation, you're pretty much done. But for an inequality, then, after you find those, you pick test values. And then you use the test values to find the correct interval. Okay? So that's the process. So let's look at a couple real quick. So here's a quick equation, just a simple one. As I see, it's not equal to 0. So the first thing I would do is x squared minus 3x plus 2 equals 0. And then I would check to see if I could factor or use a quadratic formula. This one will factor. So I get x minus 2 times x minus 1 is equal to 0. And then I set each factor equal to 0. So I get x equals 2 and x equals 1. And then I can go back and check both of those solutions in the equation. And then I can go back and check both of those solutions in the equation. So I can plug them in. So I can do, let's do like the 2, and I get 4 squared. Is that equal to 3 times 2 minus 2? The original equation, excuse me, not 4 squared, 2 squared. Apologize. So that's 4. Is that equal to 6 minus 2? Yes, so it checks. I can do the same thing with 1. The other way I can check it is I can graph it. And when I do the graph, you will see that the graph comes down like this. And we are looking for where it's equal to 0, which will occur at 1 and at x equal 2 wherever it crosses the axis. So that'll be correct as well. Okay? 2 ways to check it to make sure that you do the algebra correct. Now, in order to do this problem, you want to do the algebra correctly. So make sure you're doing algebra every time. All right, that's a big deal in pre-calculus. We're going to then use these checking strategies along the way, and eventually sometimes some of the checking strategies will become procedures. But for now, let's make sure we're doing the algebra, okay? Even on a quiz when I'm not there watching you do it. All right, that's integrity. Okay, let's switch this over to an inequality really quickly. And if I switch it to an inequality, then what happens is I have something like this. X squared is less than or equal to 3x minus 2. In the same way, I've got to get that to 0. So x squared minus 3x plus 2 is less than or equal to 0. I go ahead and factor it again. X minus 2, x minus 1 is less than or equal to 0. And then I check the x minus 2 equals 0, the x minus 1 equals 0, and that gives x equals 2 and 1. And so on a number line, that tells me the dividing points of the graph of this quadratic. And so then what I do is I pick test values in each interval. So if you remember, this interval is from negative infinity to 1, 1 to 2, and 2 to positive infinity. So when I pick a test value, I just need to pick a number in each interval. So from negative infinity to 1, I'll just pick 0. From 1 to 2, I'll pick 1.5 or 3 halves. And bigger than 2, I'll just pick 3. And you could pick any number in those intervals. Those are just what I picked. Now what you do is you plug them in to either the original equation or kind of the very last one. I kind of like to use the factored form of it. This is kind of my preferred one, but you could plug it into any of these versions we got along the way. And you see if you get a true statement or not. So if I take 0 and I get 0 minus 2 and 0 minus 1, that's negative 2 times negative 1, which is a positive 2. Is positive 2 less than or equal to 0? The answer is false. All right. Now, I can actually write that down. I do 0 minus 2 times 0 minus 1, which is equal to negative 2 times negative 1. Is that less than or equal to 0? And that's false. Okay? And then I do the next one, 3 halves. So then I do 3 halves minus 2 and 3 halves minus 1. So that's 1.5 minus 2. That's negative 1/2. And then 1.5 minus 1 is positive 1/2. So it's a negative times a positive. Is that less than or equal to 0? And the answer to that is yes. This is true. Okay? And then I go ahead and I do the last one, 3. So I get 3 minus 2 and 3 minus 1 which is equal to 1 times 2. Is that less than or equal to 0? And that is false. Okay? And so the interval that we choose is the one that is true. Now, this is less than or equal, and so since it can be equal, we would include the 2 endpoints. And so we could then say that x is an element of the interval from 1 to 2. That's our true interval. Now, if you have more than one interval where it's true, you could write both intervals and put an or between it. But essentially, this would be our solution. So any x values between those two numbers will give you something less than 0. Now again, we want to check that. And how would we check it? Well, we've already done sort of a check here by plugging a number in. But another way we could check it is we could go back to the graph. There's 1, there's 2, and this graph looks like that. And what we're looking for is, where is the graph less than or equal to 0? Where is the graph negative? So the one that I graphed is this one, okay? And so where is the graph negative? Well, between 1 and 2. That's where it's negative or equal to 0. So that's why that's the interval. So this checks, okay? Another way you could do it is you could have graphed the first one. And if you had graphed the first one, then your graph would have looked like this. You would have had x squared, which looks like this. And then you would have had 3x minus 2, which has an intercept here. And that would have been a line that goes like that. And you would have been looking for where the graph of the parabola is smaller than the graph of the line, or below it. And where does that occur? Well, that occurs between 1 and 2 on the graph. Now, that's a little harder to check than doing the one where you make it less than or equal to 0. So that's why my preference is always that one, okay? But I've checked it with a graph, and now I know that I'm correct and I can move on. So in other words, when you take the quiz, you should always have a way to know if you're correct. And so you should be passing quizzes, more quizzes with 100% on the first try than not. If you start doing the work, the correct algebra, and then learning how to check your answer graphically, then things will start to make sense, okay? This is what I want you to do. I want you to start practicing it on this first quiz. So now let's look at the second part of the test, rational equations and inequalities, okay? So what happens here? Well, if we have the equation, we want to get them equal to 0, all right? If we have the inequalities, we want to do the same thing, less than or greater to 0. Now, if we have the equation, the goal is to clear the common denominator. So clear denominators. But if we have the inequality, we want to keep the denominator, okay? And I'll talk about the reason why we keep it in just a moment. Once we clear the denominator, then we're going to check. We're either going to have a linear inequality, or a linear equation, or a quadratic equation. That's fairly typical. And so then we use those methods to finish the problem. When we come to a rational inequality and we keep the denominator, at that point we want to use factoring to break it apart, okay? And then once we factor, we're going to find the zeros, and then we're going to pick test values to choose the correct intervals. So that's sort of the correct way of thinking about where you go. That's sort of a reminder of what to do. So let's try that, okay? Okay, so let's solve this equation. So here we have an equation. So what we're going to do is we'll just get it equal to 0. And then what we want to do is clear the denominators. And now if you'll remember, that means we multiply the whole equation by the common denominator, which in this case is x minus 2, 3x minus 9. And when I do that, when I multiply by the first fraction, the x minus 2 cancels, and I'm left with 1 times 3x minus 9. And then when I do it with the second one, the 3x minus 9 cancels, and I'm left with negative 2 times x minus 2. And that'll equal 0. And once I do that, that gives me then 3x minus 9 minus 2x plus 4 equals 0. And that is x minus 5 equals 0. So x equals 5. Now, I like to check that. So I'm going to plug that in. So 1 over 5 minus 2 equals 2 over 3 times 5 minus 9. So this is 1/3. And over here, I get 2 over 15 minus 9, which is 6. This is a true statement. So I now know that I have done the equation correctly. Okay? And that's very common. I could also check this by graphing it, but this one's much more difficult to check by graphing. Let's say we're looking at this. If we graph those, 1 over x minus 2 is going to be a graph that looks like this. Okay? And eventually you'll be able to draw these quick too. And then 2 over 2/3 over x minus 3. We'll have an asymptote here. And that'll do like this. Pretty much sort of the same kind of thing. And the difference is that we're going to see them cross out here at 5. They're going to end up crossing each other right there. And that's where the solution's going to be, is where they cross. Now, this is a much messier graph, and so I much prefer just to do the algebra on that one. Okay, just personally. All right. Now, you can have a more complicated inequality to solve or that you'll deal with here. Let me see. I'm grabbing a problem. Give me just a sec. Now, just really quickly, here's a rational equation. And so we want to clear the denominators here, or we can set it equal to 0 and do it, or we can do it first. So we're going to multiply by the common denominator, which is x. But look right away on this one, we get 6x squared minus 5x equals 6. So this one turns out to be a quadratic. 6x squared minus 5x minus 6 equals 0. Now, I can factor that one, I think, but let's use the quadratic formula here because we haven't done that yet. So sometimes you'll get a quadratic, and then you got to use the quadratic formula. 5 plus or minus square root of 5 squared minus 4 times 6 times negative 6 over 2 times 6. So this one will be 5 plus or minus 24 times 6 is 144. So 25 minus 144 is 119. Is that right? This will be over 12. And 4. So yeah. So it's square root of 119. Or negative 119, which is a complex root. So this one didn't factor, all right? And so in this case, we got complex roots. I square root of 119 over 12. Now, I'm hoping I didn't make a mistake there. Looking. I'm thinking I made a mistake. 4ac b squared 2a. No, I think that's right. Okay, looks okay to me. Let me check. Okay, so I think I can factor this as well. So either my quadratic formula is wrong or my factoring is wrong. This is a perfect case where I'm like, I'm stuck. I need to check this. So let's go check it, all right? And the way I would do that, I'm going to check it with a graph first really quick, because that's an easy way to check. Okay? I'm going to shrink this down just a little bit. Well, I'm working in the browser, so we'll just have to do it. Okay. So the original problem here is 6x minus 5 equals 6 divided by x, right? That's the original problem. So I want to look at that, all right? So now I'm looking at the graph, so I'm going to squeeze it a little. Okay, the graph is really close together, so I need to kind of change my window a little bit so I can look at what's happening. And something's not right here. Let me try this. Let's just go with 6x minus 5, and then we'll put the 6 divided by x here. There we go. So now I see the two sides of the equation, and now I'm asking myself, where are the solutions? And if you look, I have one solution here at 1.5, which is 3 over 2. And this one here is at negative 0.667, which tells me negative 2/3. So what that tells me is the factoring is correct. And that means I've made some sort of error on my quadratic formula. So let me see if I can figure that out. Okay, I'm going to work on that, and then I'll show you what my mistake was. Found my error, okay? So here's where I made the error, all right? And maybe you've seen it already, and you're like, Mr. Ridpath, notice this is a negative and a negative here. So that means it's 25 plus 144, which means this is a positive 169, okay? And the square root of 169 is 13, so it's not a complex solution. So I have 5 plus 13, which is 18 over 12, and I have 5 minus 13, which is negative 8 over 12. And those were the two answers I got by checking. So this is a perfect example. I've not come across this yet, but where I made a mistake, and I could see by factoring, and I was doing the quadratic formula just to show you one, but something seemed a little off to me, and I felt like one answer was right and the other one was wrong, and I couldn't figure out what my mistake was. And so I went to graphing to see which one was right. The factoring one was correct in this case. But what I noticed, that helps me to say, okay, I've made a mistake in my quadratic formula. What mistakes do I make? Did I put the numbers in the wrong spot? B squared, 4ac, 2a, the opposite of b. So I check that. And then the next thing I check is, did I make negative sign mistakes? And the answer is, that was my mistake. I had a negative times I had the negative 24 times negative 6. And I said negative 144 instead of positive 144. So I've caught my mistake. And I've learned something in the process in terms of the kinds of mistakes I make and what to watch out for. But I can still do the algebra. All right? And that's why I'm asking you when you do these quizzes, and I'm telling you, do not just use a calculator to do these problems. If you do, when you do a written test for me, and there will be one, it will all be counted wrong because I'm asking you to do the algebra every time. Because what we are really trying to learn is the college algebra part of pre-calculus. And we need to know how this algebra works, because when we take even more advanced courses, and some of you will, there's going to be more algebra, and we want to gain understanding and skill with the algebra, okay? So there we go. That's caught our mistake, and now we've kind of cleared that up. But as you can see with a rational equation, whether it's the one I did up here or this one here, you could end up with a linear or a quadratic, okay? You just need to follow it through and go from there in terms of what method you do. So let's go back and let's do an inequality now. Okay, so now we're going to solve an inequality, and the big difference is we have to put these equal to 0, but we can't clear the denominator. All right, so if you remember, we get them less than or equal to 0, but we can't multiply both sides by x plus 2 because we do not know if x plus 2 is a positive or negative number, and therefore we don't know if we change the direction of the inequality. So the way to do these problems is to keep the common denominator. So 3x minus 5 over x plus 2 minus 2 times x plus 2 over x plus 2. So in other words, you write the 2 with the common denominator, less than or equal to 0. And so this will give us 3x minus 5 minus 2x minus 4. All of that is over x plus 2, and we're less than or equal to 0. So all I did was distribute, okay? And then 3x minus 2x is x. Negative 5 minus 4 is minus 9 over x plus 2 less than or equal to 0. Now, once we're to that point, we can take the numerator factors, set them equal to 0, the denominator factors, set them equal to 0, and we get x equals 9 and x equals negative 2. That divides our number line up, negative 2, 9, and we can now pick our test values, right? So negative infinity to negative 2, so I'll pick a negative 3, I'll pick 0, and 9, bigger than 9 to infinity, I'll pick 10, okay? Then all I have to do is take those numbers and I can plug them into this version, or I could plug them into the original, or any step in between as long as it's correct. So I usually choose the factored version, but it's okay, whichever one you choose. So then negative 3, so I do negative 3 minus 9 over negative 3 plus 2. Now, that's equal to negative 12 over negative 1, which is a positive 12. Is positive 12 less than or equal to 0? No. So this is false. So I take the 0. 0 minus 9 over 0 plus 2 is negative 9 over 2. Is that less than 0? Yes, that is true. All right. And then I grab the 10. I do 10 minus 9 over 10 plus 2. And I get 1 over 12. And is that less than 0? No. So that's false. Now, you may be wondering by now, do these always alternate like this? And the answer is actually no. It just so happens that for a lot of our problems, it looks like it always alternates, but it doesn't always alternate. Okay? And so that's why you have to check every time. Okay? Anyway, we now know the true interval is from negative 2 to 9. So I can write that interval notation, negative 2 to 9. Now, can it be equal to, since this is less than or equal, can it equal 9 or negative 2? Now, it could equal 9 because I get 0 in the numerator. So this one's a square bracket. But can it equal negative 2? The answer is no. Negative 2 is not in the domain because that makes us divide by 0. So open parenthesis. God, turn my alarm off. Finally, you have to do radical equations and inequalities. All right, radical equations and inequalities. And if you remember, if you're doing an equation for a radical, the key is to square both sides. All right, or cube both sides if it's a cube root. But before you do that, you must isolate a radical, especially if there are two in the equation. So you got to isolate one, and then you square both sides. And then if you have still have a radical, then you do it again. And so you do that until all the radicals are gone. All right. So that's how you do the equation. And then at that point, it'll either be linear or quadratic, just like the rationals. And so you go back to solving a linear or a quadratic. On an inequality with a radical, same thing. Square both sides. Okay? And for the same reason, you're going to isolate a radical and square both sides. And eventually, once it's a linear or quadratic, you use those methods to solve. So let's take a peek at an example. So here's a typical example. And so we need to isolate the radical, which means we get it by itself. And once the radical is by itself, then we square both sides. So I'm going to write the squaring. Sorry about that. Squared and squared. And again, I want you to notice this is an eyeball opener. Draw the eyeballs, right? This is the eyeball opener. This is a quantity squared here, which means it's x plus 2 times x plus 2, and you have a middle term. So squaring the radical, square root times itself, just gives what's under the square root. And this then becomes x squared plus 4x plus 4, because you'll have 2 times 2x twice. And then now we can see this is a quadratic, so we set it equal to 0, x squared plus 3x, subtracting x from both sides, subtracting 1. And then now we have this quadratic. This one does not factor, so I would need to use the quadratic formula. X equals negative 3 plus or minus the square root of b squared minus 4 times 1 times 3. And that'll be 2 times a, 2 times 1. And what we see under this radical here is that our discriminant is 9 minus 12, which is a negative 3. So this gives us negative 3 plus or minus the square root of negative 3 over 2. So these are complex number solutions, all right? So negative 3 plus or minus I square root of 3 over 2, all right? So we have two complex numbers that are the solutions of this particular radical equation. Now, just so you remember, if it says solve for all solutions, then you would keep this. But if it says solve for all real solutions, so now it's asking for real numbers. Complex numbers are not real, so then our answer would become no solution. So you need to be aware of what the situation is. Now, you could have used the discriminant first, just done the b squared minus 4ac, and discovered it was negative, and so you could have said right away that there are no real solutions, okay? No real solutions, if that's what was required by the directions, okay? All of these problems, every one of them that we've just done, you can check by graphing, okay? Except for this one. So I do want to talk about that. So I'm not even going to draw it on Desmos. I know how to draw this. The right side is just x, so it's this line, y equals x. The left side is x plus 1 minus 2. And so like this, so if you remember, that means we move a square root graph, which looks like this. We move it to the left 1, because it's x plus 1, and then we drop it down 2. So we're going to go to the left 1, but we're going to go down 2. And so that graph is going to start there, and it's going to be just a regular old square root graph from that point. And so I know based on a regular old square root graph, it's going to look like that. And what we can see is that these two graphs do not intersect. Since they don't cross each other, that means there are no real solutions. That's a case where you know that your discriminant's going to be negative and you're going to end up with complex solutions, okay? Complex numbers for your solutions. Anyway, hopefully that helps you. That's sort of the in-depth kind of overview from the sky as to what these look like. So good luck on the quiz. This was a quick review of all those things we've done. For all the problems on the quiz, do the algebra, okay? I am perfectly fine if you check your algebra with graphics before you pick an answer, because that gives you a way to find mistakes and other things like that. All right? So good luck on the quiz. Let's all get 100% and move on being ready to go. Thank you. Talk to you later. Bye.